Relative basicity base, aliphatic base. These are the aliphatic base. NH3 methyl, NH2, 2 methyl are acting, 3 methyls are acting, here 1 methyl is acting. So as these are providing plus I effect, this is providing plus I effect. So basicity means how much easily it can donate its lone pair to the other compounds, the electron deficient compound in acid, how much it can easily donate to the acid. If any acid is there, how much can easily donate its lone pair to the acid, the as the Eg, how much Eg, if it is, it can donate more easily to this acid, it will be more basic than this, so the basicity increases. This 3-methyl, it will provide plus I effect, so increases ability to donate its lone pair to the acid, so it will be more basic. So 3-methyl is there, 3, 2, 1 and 0-methyl. So in this way 3-methyl is provide more plus I effect, 2-methyl, 1-methyl, so it will increase the basicity to provide a lone pair to the acid, because after providing a lone pair it will become a plus charge. After providing, if you provide this, it will become a, in this way, 3-methyl, it will become a plus charge. So this plus charge is more stabilized by this methyl group. This plus I effect, this is a plus I effect, plus I effect, it will stabilize this negative charge. So as this plus I effect increases, the stability of plus charge increases. As the stability of plus charge increases, this basicity increases of this compound. So the basicity increases as the plus I effect increases, this 3 to 1. So that's why this is a more basicity than this. The basic strength will be 3-methyl, 2-methyl, 1-methyl, 0-methyl. So always need to be take care. This is the order of basicity in the gas phase. This is the gas phase. This is the basicity in the gas phase. We have to check the basicity not in the open state. Actually, this is take the basicity. We have check the basicity order in the gas phase. Why we are saying the gas phase? Because in the water phase, if you take the water phase basicity, if you take this order in the water phase, this all the things are taken in the gas phase. The phase are the gas. If you take water, then basicity order will be 2-methyl, 1-methyl, 3-methyl, 0-methyl. It will come in, this is coming in order of, this is coming in order of 3, 2, 1, 0. Actually the basicity order will be 3, 2, 1, 0. 3-methyl, 2-methyl, 1-methyl, 0-methyl. The order of basicity will be 3, 2, 1, 0 in a gas phase. In a gas phase this is a basicity. But if you take a water phase, this is a basicity in the gas phase, 3210. 3210 is the gas phase. If you take a water phase, then the basicity order will be 2130. 2-methyl, 1-methyl, 3-methyl, 0-methyl. 2-methyl will be higher basicity than the 1-methyl, 3-methyl and 0-methyl. This is the water phase. Here I have written the water phase. When we will take water phase, and this will be in the gas phase. This is in water phase, need to be take care. This remember, because in examinations they will provide phase. If water phase, gas phase, if you know anything is mentioned, then the answer, then the phase will be gas. If anything will mention if as a water, then the phase will be water and the water will be come in this order. So if any student didn't know about the water phase, gas phase, then that student definitely will make a wrong in the examinations. Any question will ask related to this, then they will definitely then the questions will answer will be definitely wrong. So why the order are changing in a gas and the water, why the order changing in a water phase? Water phase the random order will be coming 2130, but in the gas phase 3210 order is coming, 3-methyl, 2-methyl, 1-methyl. I am denoting this 3210 for the remembering purpose, the 3210 but for in the written examinations didn't write this thing, 3-2-1-methyl in this order, but for the remembering purpose, for the making more clear to make understand easily, 3210 I am showing is a 2130 I am showing, 2-methyl, 1-methyl, 3 and 0-methyls. So why this order are changing? The in the gas phase, the simply you have to take the plus I effect and to determine the acidic strength. In the gas phase you have to simply determine the basic strength by the taking the plus I effect. But in the water phase there is a effect is called solvation. As the hydrogens increases, solution increases. This NH3R, this is a 3 hydrogens, this having only 1 hydrogen, so this is having less solution. Solutions means water molecule surrounded with this ammonia molecule. This is ammonia molecule, this is a water molecule is surrounded This is due to the fact that basic strength of amine in water is determined not only by the ease of electron donation of nitrogen atom but also by the extent of which cations of form can undergo solution. Here the cation is form is solutions become sterilized by hydrogen attached to the nitrogen. Greater is the possibility of solution by the hydrogens bonding with the water. Alkyl group are hydrophobic and inhibit hydrogens bonding, hence solution. There is alkyl group inhibit hydrogen bondings. This hydrogen group will bond with oxygen and it will provide a hydrogen bonding. It will hydrogen bonding, so this cation will be more stabilized. Here is a 3 hydrogen bonding, so this cation is more stabilized. So in this order the order of basicity changes. As the hydrogens increases, the stability increases of the cation by the hydrogen bonding in a water phase. But this is thing doesn't happen in the gas phase. There is nothing gas phase, only you have to take the electron donation capacity of this group increases, basicity increases. But in the water phase there is a solution one effect where the hydrogens increases, solution increases, plus charge will be stabilized. So to think about this all the aspects to check the order which compound will more basicity. So by the experiment, if you check this thing, they are experimentally check this 4 group which one is more basic, then the experimentally the answer will become 2 methyl 1 methyl 3 methyl 1 methyl 2130, because of solution this order is coming. So we need to remember this order 2130. Here 3 methyl 2 methyl 1 methyl 0 methyl. It is interesting to note that gas phase basicity order of amine follow the usual order. 3 2 1 0 orders is following. Here ethyl is here 3 2 1 0 in the gas phase, and ethyl in the water solvent 2 1 2 3 1 0. Here 2 3 1 0 need to be remembered. Here in the methyl 2 1, here is methyl 2 1 3 0 2 1 3 0, but in ethyl there is a 2 3 1 0 2 1 3 0 in methyl, and in ethyl there will be 2 3 1 0 2 3 1 0 in ethyl. So this thing need to be take care. 2 3 1 0 methyl also order changes. These are all are the experimental orders. So we need to be remember this thing. Water phase 2 3 1 0 and 2 1 3 0 go for methyl. Methyl means 1 carbon 1 2 1 3 0. But ethyl 2 carbon means something changes 2 3 1 0. The order will be here changed. 3 will come 1 will go to 3 2 1 3 0. In this way we can remember. If gas phase is there, then nothing need to be remembered. 3 2 1 0 order will be there. Now to check the strongest base, which one is the strongest base, we need to this pyridine and aniline parallel. This pyridine will be strongest base, then the anil, then the parallel. This pyridine has a lone pair. How easily can donate this lone pair is called basicity. So basicity increases the Ag as the lone pair ability to donate increases. So this pyridine lone pair is not participating in the resonance. These 3 bonds are participating in the conjugation, but this lone pair is outside. This can easily donate its lone pair, but here this lone pair in conjugation with this aniline. I will make you the drawing, but here for the normal introductions, this aniline lone pair is participating in the resonance, but this lone pair also participate in the resonance inside. It will fulfilling the aromaticity, so it will not leave this. It has very less basicity to donate a lone pair because it is participating in the inside, but this lone pair participate from outside. So it has between these 2 compound, this will be more basic than this. It is outside, it is inside participating in the resonance. This is from outside. Only for the stability purpose this lone pair is participating, but this is making the aromatic compound to make more stable compound. It is participating. Now I will make you understand one thing. This lone pair is participating in the resonance. This form is forming electricity. There are lots of structures. That's why this is a in this way. This pyridine is outside. This is a inside. So this is a more basic than this. This is a inside. This is a participating in the resonance. This is doesn't participate in the resonance. So it is a outside. Here it is in the resonance. It is participating. Pyridine is shown. Here this pyridine only this structure is participating. A lone pair is outside. So it will. Now one example here is here this example. This example, which one is more basic? This lone pair is more basic than this lone pair, then this lone pair. Have to compare. This is a x y z. Name is given x y z. Which one is more basic? We have to increase. We have to order the lone pair. As the sp is more acidity than the sp2, then sp sp3. sp is more acid then sp2 then sp3. We have to check the basicity. So this will be more basic than this. So acidity in this order and basicity in this order. This order acidity increases, this order basicity increases. So this is sp3 hybridized, this is sp2 hybridized. So this is sp2 hybridized, this will be more acid. So y will be in the last. So this is a this is sp2, this is a sp3, and this is a sp3. So now we have to check this two things. This lone pair in conjugation, but this lone pair, this nitrogen lone pair doesn't have in conjugations. This is an altered project. This is a sp2 hybridized. So it is in this lone pair in conjugation. This lone pair doesn't having any conjugation. So this will be more free to donate this lone pair. So it will be more basic than the Z. X is a more basic than Z. Now it is clear. Now have to check this lone pair and this lone pair. As this lone pair is outside the ring. This is making the, this is a pyridine lone pair. This is a pyridine lone pair. This is actually outside of this resonance. This is a resonance already complete. Now this is outside. It can easily donate this lone pair. Here is the lone pair not in conjugations. Here the lone pair in conjugations. This lone pair doesn't having any conjugation. It can easily donate this lone pair. It can easily donate this lone pair very easily. It can donate this lone pair. So that's why y will be more basic than the x. As the y is more basic than the x, then this will be y is more basic than the s. So y x z. In this way we can get to know about the basicity. Here hybridization is shown, but it is not much very important to know the hybridizations. Only have to think about the which lone pair can easily be donated and become a more basic. So we need to take care of this example. Now this example I will explain. This thing I have already explained. Now this is the lone pair. Here the lone pair, there lone pair. This lone pair can easily donate. This lone pair is participating in the resonance contributing structures. So it can easily donate. So it will be more basic than this. Now we will learn about the aniline. Any ortho substituted aniline. Any ortho substituted aniline is a weaker base than the any other aniline. If you ortho substitute whatever the group, this will be the very less basic than the other. Why this is very less basic? Because it will provide hindrance. Ortho substituted aniline are weakest base than the aniline itself. Ortho substitute cause a steric hindrance to the solution its product. There is the ortho substitute will cause a steric hindrance for the solvations. Conjugated acid cation, it will cause solvations problem. A small group like NH2 and OH doesn't experience the steric hindrance, so need to be take care. If NH2 and OH group is present, it will not cause ortho effect of aniline. Ortho substitute aniline are the weaker base. This need to be remember. This is very important. Now I'll go to examples. This is ortho substitute, so it will definitely be a weaker base. Now this is a weaker base. This is ortho. Now this is coming the last. This group providing minus I effect. This providing minus I effect and minus M effect. This is providing both the effects. So this will withdraw the electron. Try to withdraw the minus group will be try to withdraw electrons. So it will not make them easy to donate this lone pair to become to show a basicity. So how easily can donate this lone pair? It will be more basic. So minus M effect withdrawing the electron, so the basicity decreases. So this is providing minus I effect, and minus M effect. Minus I effect. This is minus in the meta positions. Only minus I effect will work. Minus M effect will not work. Minus M will not work. Here minus M minus I is providing. So it will make them less basic than this. So this will be more basic. So meta position will be more basic than the para position. And aniline doesn't having minus M effect, minus I effect. That's why this will be more basic. This will be more basic than this all this compound. And this will definitely be less basic because ortho substitute, and this is providing minus I effect, there minus M minus I. Minus M will make them less basic. That's why meta will be more basic than the para. Meta more para. Aniline is doesn't having minus I minus M effect. It will come in the first positions. Similarly, CCl3 ortho substitute, it will come in the last. So to compare this three group has a minus group. This is a minus group. This is also minus I effect. Minus I effect are the distance dependent, so it will provide more minus I effect than this. So between these two group, this will be more basic than this. Between these two group. Now this is doesn't have a minus I group, so it will be more basic. This is aniline is more basic than this group. para group, then the meta group, then the last our ortho group. In this way we can determine. This is chlorine. Chlorine halogen doesn't having ortho effects. This is having doesn't having ortho effect in the carboxylic acid. In the benzoic acid, halogen doesn't having an ortho effect. So, but in the aniline there is an ortho effect. So it will be. So we need to take care that this is a benzoic acid will be there. Then this will be more basic, more acidic. But here the basic strength we are checking. So chlorine is minus I effect is providing is a minus I effect. So this doesn't have a minus I effect, so it will be more basic, because minus I effect will decrease the basicity. So it will be aniline will be more basic than these three compounds. These are the distance dependent. So this group is distance dependent. So this should be our more basic. This should be our basic. This should be our less basic. Is the ortho substitute, so it will come in the last. Ortho substitute will come in last. Between these two have to compare. This is a distance dependent, so it will be more basic. It will less decrease this electron capacity to donates. So para positions and meta positions, now ortho positions. Now CH3. Now CH3 will provide plus I effect and hyperconjugations Here is also providing hyperconjugation, but here hyperconjugation will be not there. Why the meta positions no hyperconjugation is there? This is ortho substitute will be less basic. Now it will be the less basic, and ortho substitute is the last. This is our last. So to compare between these two compounds, this is providing plus I, and hyperconjugation this is providing only plus I. So it will be more basic. Para will be more basic than the meta. It doesn't having plus I plus hyperconjugation, so it will be in the last. And then the ortho will come in the last position. So in this we can determine. Now this is OMCH3. OMCH3 means OR. This will provide at meta positions it will provide minus I effect, and the ortho and para position it will provide plus M effect. So this need to be think here. So ortho substitute will be OR and NH2. Now this aniline. Now these structures can be drawn like this. Structures can be drawn like this. Four structures. Now it is this structure can be drawn like this structures. This OMe OR similarly this will act as a plus M group and minus M group, plus M group minus M group, plus M group and minus I effect are acting. This group this position plus M and minus I effect will be working, minus I effect will be working, plus M minus I effect will be working. This aniline there is no any groups is there. This will provide a ortho effect. That's why this will be should be less basic because of this ortho effect. And this is providing minus I effect. This minus I effect this will become in the last, because all these groups this will come in the last. If in the order 1 2 3 4 compound is there, this will come in the last. This meta will come in the last positions. We have to 1 2 3. This 3 we have to check. Plus M effect has higher priority than the minus I effect. So this will come in the, if 1 2 3 if to compare between these 3, then this ortho will come between these 3. Ortho will come in the last position, so it will be in the ortho position. That will be ortho position. Now I have to compare this 1 and 2. This will provide plus M effect. It will provide no N effect. It will plus M effect increase the basicity. So this para will be in the first positions and this aniline will be in the last position. So the correct order will be para, aniline, ortho and meta. So in this way you have to check the basicity of aniline. If here is the, if OH group will be present, the order will be different. This OH group doesn't provide any ortho effect. If this OH will be present, then the order will be this OH will be present. OH is present, then the order will be different. This ortho will come in the first positions. Ortho will come first positions, then aniline, then our will be meta will come in the last positions. This will come in the first positions, then will be para, then aniline, then ortho, para, aniline. Ortho will be higher priority because this is doesn't providing OH doesn't providing steric hindrance in aniline. So OH will be in our this para, ortho will be plus same effect will be higher priority. This group will be in the first positions, then the para group, then this aniline, this minus I group will come in the last, meta will come in the last. In this way we can determine the basicity. Now we will learn about the alkyl halides, something about alkyl halide nomenclature. Then after we will learn about the alkyl halide properties. All these properties we will learn one by one.